Today we're going to talk about changed attribute. Changed attribute is when you have one shape and you're going to adjust one or more of the lengths and see how it affects either the volume or the surface area. So let's look at the first example. Let's find the volume of the prism. If you remember, the volume, to find the volume of a rectangular prism, you're going to use the formula length times width times height. I'm going to label my length, width, and height on here so I'm always consistent. So my length will be 6 inches, my width will be 4 inches, and my height will be 25 inches. So now I'm going to plug in or substitute my dimensions and multiply from left to right to get 600 inches cubed. Remember, volume, your exponent is always cubed because you're multiplying inches 3 times. So inches times inches times inches is inches cubed. Now let's say the width was multiplied by 2. So I'm going to take the 4 and multiply it by 2. And so now my new width is going to be 8 inches. The question wants to know, if I double the width, does this double the volume? So now, let's try to find the volume with our new width. So length is still 6, width is now 8, height is 25. When I multiply this from left to right, I get 1200 inches cubed. In order to see if it's been doubled, you want to take your new volume, which is 1200 inches cubed, and you want to divide that by your original, which is 600 inches cubed. 1200 divided by 600 is 2. So that means, yes, by doubling the width, it did double the volume. Make sure you always circle or square your answer. So now let's look at if the length was multiplied by 2. So let's go back to our original width of 4. Our length is 6. If we double that or multiply it by 2, we get 12 inches. So let's perform the volume of a rectangular prism with our new length of 12, our original width of 4, and our height of 25. When I multiply this from left to right, I get 1200 inches cubed, which we determined 1200 divided by 600 does equal 2, which means, yes, by doubling the length, it does double the width. Does double the volume. One thing about volume is that it is always consistent. If you double a side value, it will double the entire volume. If you triple a side value, it will triple the volume. Looking at example 2, if 1 millimeter is added to the length of each side of the rectangular prism, with a length of 3, width of 5, and a height of 4, calculate the volume changes. So our original volume has a length of 3, a width of 5, and a height of 4. So when I find the volume, it's length, width times height. Plug in your values and get your answer. Multiply this and you get 60 millimeters cubed. Now I want you to calculate the new volume. I want you to add 1 millimeter to each side. So now volume equals length times width times height. I get a final answer of 120 millimeters cubed. So very similar to what we did on problem 1, in order to figure out how much the volume had changed, you want to divide the new volume by the original volume, and whatever your outcome is, that's how much your volume has been changed. So for instance, in this example, the volume is 2 times larger. Now let's look at surface area. Surface area is different. You still find everything the same way you did as volume, but it is not an exact change. For example, if you double a side, the surface area does not always double. So you have to use this comparison of division in order to be able to figure out how the surface area has changed. So I want you to find the surface area from example 1. In example 1, the length was 6, the width was 4, and the height was 25. The surface area formula for a rectangular prism is 2 times length times width times 2 times length times height plus 2 times width times height. You do not have to memorize these formulas. You will be given a formula sheet on all your assessments and on your SOL. Substitute in all your dimensions. Now your order of operations, or GEMDAS, states that you need to multiply everything first. So 2 times 6 times 4 is 48, plus 2 times 6 times 25 is 300, plus 2 times 4 times 25 is 200. Now you add them together. Yes, you need to show all 4 of these steps on all your assessments. So when I add these together, I get 548 inches squared. Remember, for area or surface area, it's always going to be squared. So if the width were multiplied by 3, does this triple the surface area? So that means my length is going to stay at 6. My width, you'll take 4 times 3, which is 12, and my height will stay at 25. So once again, let's write down the formula. Now plug everything in. Now let's do all of our multiplication first. So you'll get 144 plus 300 plus 600 to give you a total of 1,044 inches squared. So in order to determine how much your rectangular prism has changed, you want to take your new surface area, divide it by your original surface area, and you get an answer of 2. So no, this does not triple the surface area. Let's look at the last example. Because this is asking for surface area, it's going to be a little bit tedious. You're going to have to show some work, but that's okay. A company has produced a cereal box with the following dimensions: a width of 4 inches, length of 6 inches, and a height of 12 inches. The surface area of the box needs to be reduced to under 200 square inches. Which situation will create an appropriate surface area? Let's add situation or situations. So if you were to multiply the width by a scale factor of 1/2, remember, multiplying by 1/2 is the same thing as dividing by 2. So half of 4 for the width is going to give you 2. So this will be scenario A. Scenario B is where you take the length and multiply the length by a scale factor of 1/3. Remember, multiplying by 1/3 is the same thing as dividing by 3. So for your length, which is 6 inches, if I multiply that by 1/3, I'm going to get 2 inches. And in scenario C, you're going to multiply the height by a scale factor of 1/2. So my height is 12 inches. If I multiply it by 1/2, I get 6 inches. So you're going to have to do 3 separate surface areas to figure out which one or ones has reduced the surface area of the box to under 200 square inches. Pause the video, give it a try. Check your answers with the work over here on the left. Here's A, B, and C. So it wants to know which ones are under 200 square inches. A is out because it's 216. B is at 160, so that is less than 200. And C is at 168, which is less than 200. So your answer should be B and C. Now let's flip a few pages. So here's page 15, 16, and then 17. Should say mixed practice at the top. I want you to go all the way down to the bottom to number 20. Number 20 states if the surface area of a new rectangle prism can be represented by the formula surface area equals 6 times length width plus 2 times length height plus 6 times width height, which statement is true? So in this case, you have to use a few of your properties. If I rewrite the formula, you notice that the 6 times length width plus the 6 times width height, they both have 6's in them. So we're going to actually use the commutative property of addition and move these so they are together. now we're going to use distributive property, and they're actually common terms, and we're going to take out what both of these have in common, but make sure you got to remember that the original problem has a 2 length width, 2 length height, and a 2 width height. So in order to keep these at a 2, you're only taking out a 3, and then they both have a W, so you take out a W, put parentheses on the outside, and that leaves you with 6 divided by 3 is 2. Okay, you took out the W, so it just left you with the length. 6 divided by 3 is 2. You took out the W, which leaves you just with height. So you can see that your formula was tweaked by multiplying the width 3 times. So when you go look at your answers, you want to see which one has the width. This is length. This one's height. So the width has an original rectangular prism that was multiplied by a scale factor of 3. So you may have to rearrange a few things to figure this out.